Hello friends, welcome back to my new video. So in this video I am going to learn to find out the bond angles of different molecules. So without any delay, let's get started. We have a molecule that is water, H2O. So firstly we will find out the bond angle of this molecule, H2O. And in this video I'm also going to tell about the three tricks for finding the bond angles in different molecules. So first I have taken a water. So first let's start. First step is to check the hybridization of central atom, that is hydrogen. Sorry, that is oxygen. So a trick which I have also told you in a previous video, that Z equals to number of valence electron on central atom plus any negative charge if it is present, minus positive charge, and plus monovalent atom. Monovalent atom means an atom whose valency is a 1. That could be hydrogen, chlorine, fluorine. Okay. Monovalent atom divided by 2, right? So in this molecule we have a central atom, that is oxygen. So the valence and the electronic configuration of oxygen will be 1s2, 2s2, 2p4, 2p4. So the valence electron is 2, 6. The valence electron is 6 of oxygen. 6. No negative charge, no positive charge. So there is no need to do anything. And here we can see that 2 atom of hydrogen is present. So we know that hydrogen is a monovalent atom. So we can do plus 2 by 2, right? 6 plus 2, 8. 8 by 2, that is 4. And as I have also made a video in this topic in the previous video, you can see that if the value of Z comes 4, that means what? That means hybridization is taking place of sp3, right? So we know that sp3 means geometry of sp3 is a tetrahedral. So the geometry of H2O will be tetrahedral, but according to VSEPR theory, that is valence electron pair repulsion theory, here is a one lone pair, and another formula of calculating lone pair is Z minus the value of Z minus number of surrounding atom which is attached on the central atom. Number of surrounding atom. So lone pair is equal to the value of Z is 4 minus 2. 2 is the atom which is attached with the central atom, that is oxygen. So friends, here is 2 lone pair, and we also know that according to VSEPR theory, the repulsion happens between more in lone pair is greater than lone pair, bond pair is greater than bond pair, right? So here is a two lone pair. That means what? The repulsion of two lone pair will be more greater. That will, and the shape will be visible about like this. It is a two lone pair which is present, right? And it is oxygen atom and it is hydrogen atom. And the degree which is, the angle which is going to be formed is less than 109 degree 28 minute 28 minute, because the experimental values we cannot calculate here. And we know that in tetrahedral geometry 109 degree 28 minute degrees form, but here is a two lone pair which is present. That's why the angle will be decreased. So approximately we can calculate that 109 degree 28 minute. This shape is known as bend shape. Bend shape. Bend shape. That because the lone pair which is present here and the repulsion is very much, and these two lone pair will repel these two bond pair. That's why it will be less than 109 degree 28 minute. So I have told the first step, that is to check hybridization, and second step to check the lone pair which is present. So assume that in examination you may got NH3 and PH3. It is just a type of example which I have taken here. So let's take NH3 and PH3. So let's check it. Right. So friend, first of all we will calculate the value of Z on central atom, that is the electronic configuration of nitrogen will be 2 and 5. 5 is the valence electron and 3 monovalent atom. 5 plus 3 equals to 8, that is by 2, that is 8 by 2, that is 4. That means what? Here is sp3 hybridization. And we will calculate the value of Z of PH3 phosphorus. So it is a value of Z of nitrogen. So let me write nitrogen, and it is the value of phosphine which I am going to calculate, right? So the atomic number of phosphorus is 15, and configuration will be just like 2, 8, 5. 2, 8, 5. So we will write here 5, which is the valence electron of central atom. Okay. And the number of monovalent atom which is attached, that is hydrogen. So we will write here plus 3 equals to 4. That means what? sp3. So in both of molecule, according to our first and second trick, the geometry is going to be formed that is tetrahedral. But one thing that we are missing, that is to find the lone pair. So I have told the formula of calculating lone pair, that is Z minus number of surrounding atom which is attached with the central atom. So lone pair, we will calculate lone pair. So Z minus, it is a lone pair which we are calculating of nitrogen. So I am writing nitrogen. Okay, Z minus 4, Z minus surrounding atom, surrounding atom, right? So the value of Z which we have calculated, that is 4 minus 3. 3 is the surrounding atom, that is hydrogen, that is attached with the nitrogen. So one lone pair is present in NO3, sorry, NH3. So I will calculate the lone pair on pH3 equal to 4, that the 4 is the value of Z, 4 minus 3, again 1. So whenever you will see that when hybridization is same, lone pair is same, then you may think that angle is going to be formed same in these both of molecule. But no, it is not going to be happen, because if this type of condition will be take place, then a trick that is I'm going to be share with you, that is if electronegativity. So first of all, see that, notice in both of molecule, that is pH3 and sorry NH3 and pH3, the common thing is that surrounding atom is same, but central atom is not same. Central atom is not same. So if central atom is different, then central atom is different and electronegativity is more. Electronegativity is more of any molecule of central atom, of molecule of central atom, then angle will be large, angle will be more, right? So will be more. So we know that nitrogen have more electronegativity than phosphorus. So we can say that the angle which is formed by the molecule of NH3 will be greater than pH3, because the electronegativity of nitrogen is more than phosphorus. So we can write it like this: NH3 is greater than pH3. So let's make the geometry of this. So as we know that both are tetrahedral, right? So hydrogen, nitrogen, right? So here is a lone pair. One lone pair is present. One lone pair. Let me put the hydrogen like this. hydrogen, hydrogen and hydrogen. With single bond it can made. Okay, and degree is 107, 109 degree 28 minute. And in pH 3 molecule, in pH 3 molecule, in pH 3 molecule it will be 98 or 92 degree. Now you will ask that why this happened. So at, for this, as we know that the electronegativity ooze is more, the angle will be formed larger than another. So the electronegativity of nitrogen is more than phosphorus, so nitrogen will form greater angle than phosphorus. Okay. And because as we know that in VSEPR theory, when electron attract each other, you understand like this. Suppose that it have more electronegativity and it have less electronegativity. And if it have more electronegativity, then the electron will be attract here, here and here, both will be attract here. And it have a less electronegativity of pH 3, and the electron, it means it have a greater chance to gain the electron. It have a greater chance to gain the electron. So electron will be meet here, here and here. And as we can see that this electron is nearer to the central atom, right? And the repulsion between these electron will be more. And when these electron will repel each other, the angle will form 98 degree or 92 degree. It is happening due to the Dragos rule, which we will discuss in the later videos. So let's take another example, that is Cl4 and BCl3, carbon tetrachloride and BCl3. And here we can notice that surrounding atom is again same and central atom is different, right? So again we will calculate the value of Z. The valence electron which is present in carbon have 4 plus 4 by 2. Here chlorine is a monovalent atom, and the value of Z is again coming 4. That means sp3 hybridization, right? It is of BCl4. So we will calculate the lone pair Z minus surrounding atom, that is 4 minus 4, that is 0. So it have a 0 lone pair. And in BCl3, Z equals to Z equals to 3. 3 is the valence electron of boron, plus 3 monovalent atom is there, right, by 2. So 6 by 2, 3. and here is sp2 hybridization is taking place, and lone pair is again 0 because the number of atom attached with the central atom is equals to the value of z. So its shape will be, first of all we will calculate the geometry of carbon tetrachloride CCl4, that is a tetrahedral sp3. So C C it will be 3D, and the degree between them is 109 degree and 28 minute. 109 degree and 28 minute. It is the geometry of CCl4, and now we will see the geometry of BCl4 boron tetrachloride, BCl3, sorry. So here is also a sp2 hybridization is taking place, that is trigonal planar. So it looks like this: Cl, Cl, Cl and boron. It is trigonal planar, that is equals to 120 degree. So we can see that BCl, the angle of BCl3 is greater than the angle of CCl4, right? So another thing which I have told earlier, that NH3 and PH3, that why there was so much difference between the angles of both these molecules, right? So assume that it is assume that in pH3 there is no hybridization is taking place. It is just all about the Dragos rule. Just see that it is NH3, it is NH3 and it is PH3, right? It is PH3 and it is NH3. Again we will do like this: it is nitrogen, it is phosphorus. One lone pair is present, three hydrogen, right? And it will be 107 degree because one lone pair is present, and it will be 90 degree. It will be 90 degree, about 90 degree. And as we can see that there is a very more difference between the angle of these both molecules. This is happening due to the Dragos rule. So first of all we will write the electron according to their energy level. So first of all we will calculate the energy level of nitrogen in NH3. Nitrogen, atomic number of nitrogen is 7, that is 1s2, 2s2, 2p3, 2p3. According to Hund's rule, electron filling will be like this, right? So in p subcell 3 electron is present, it will be like this. Okay. And in phosphorus whose atomic number is 15, will be 3s2, 3p3 will be its valence electron. I am not writing here the configuration. Lone pair is 1, lone pair is 1, lone pair is 1, and lone pair is 1. And it will make a bond with 3 atom, and it will also make a bond with 3 atom. And as I have also earlier told, that the angle will be decided on the basis of electronegativity of the atom. Here the electronegativity of nitrogen is greater than the electronegativity of phosphorus, because as we move downside of periodic table, the electronegativity will decreases. So in 15th group, nitrogen comes, and as we move downward, the electronegativity of 15th group decreases. So beside the nitrogen, phosphorus is present, so the phosphorus is less electronegative, it have a less electronegative, and it is a more electronegative. So the bond angle of NH3 will be greater than the bond angle of PH3, right? So now we can see that more difference between the angle of both these molecules. And I'm going to tell about a fact. It is a nitrogen and it is a phosphorus. Both are the central atom of these both molecules. And hydrogen, 3 hydrogen will make a bond with this. Here is the sp3 hybridization is happening. sp3, each orbital will be sp3. So it will something look like this. It will something look like this. 2 1 1 1, right? So here is the hybridization is happening, but in pH3 phosphorus makes it a bond with a hydrogen, means hydride, with a pure p orbital. Here is no any type of hybridization is happening. Now you will ask that why there is no hybridization is happening, because now you can here see that sp3. So first of all, we will calculate the electronegativity of these two orbital, sp3 and 3s2, right? The lone pair which is present, we will calculate the electronegativity of lone pair, that is S subcell. So here is 2 lone pair, that means what? That means it is of 25%. It is 25%, because when we will calculate the electronegativity of one electron in 4 orbital, then 1 by 4 into 100, when we will calculate in such a way that it will come 25%, and here is 100%. So we can clearly see that the electronegativity of S subcell in nitrogen is less, and the electronegativity of nitrogen is less, and the electronegativity of phosphorus is more. And we also know that the electronegativity decide the gaining, losing, or sharing of electron, right? In nitrogen 25% is electronegativity. Just assume that 25%, it means that it have more tendency to share its electron. That's why it will be make hybridization to make NH3. But in the case of pH3, that have 100% electronegativity of one electron, and it will do that. It will not share its electron with anyone, with any orbital. So no hybridization will be takes place in pH3, right? So the P3 means P subcell have 3 electron, and it will be made the bond with 3 hydrogen which is present in it. So the bond will be made at 90 degree. This is all about the Drago's rule. So as I have made the geometry of pH3, due to this the angle is lower than the angle of nitrogen. Now you could understand that. Now you will ask that what are the conditions of Drago's rule is applied, when and how it is applied. It is generally applied with the hydride with the 15th group of element. 15th group of element. Now the question arises then that nitrogen is also present in the 15th group, then why there is hybridization is happening? This is because the because Drago's rule is applied in 14, 15, 16 group of element except first element. I mean to say that here is a periodic table, and 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14 15 16 group of element except first element. So in the case of NH3, here is N which is present at the topmost at the first element. So here Drago's rule will be not applied. Whereas in phosphorus, which is present just below of nitrogen, and it makes the bond with 3 atom of hydrogen, that is hydride. I hope you have understood. So meet you again in next video. Thanks for watching.